Hi, my dear students. We are going to the chapter-wise concept. The topic is pair of straight lines. Now we are going to non-homogeneous pair of straight lines. So this is the very important theorem, the beginning theorem from non-homogeneous pair of straight lines. Already the difference between homogeneous pair of straight lines and non-homogeneous pair of straight lines in previous class completed. Now we are going to the non-homogeneous equations. So this is the first basic theorem. This is very important theorem. Important theorem for 7 marks in IP board exam. At the same time, this is a little bit difficulty is there. So you have to concentrate there. First of all, observe the statement of the theorem. If the equation S, it represents ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents a pair of straight lines, then delta represents abc plus 2fgh minus af square minus bg square minus ch square is equal to 0, and second condition, h square greater than or equal to ab and g square greater than or equal to ac and f square greater than or equal to bc. Actually observe, so S is the notation of the pair of lines. So that means S represents ax square plus 2hxy plus by square is equal to 0, and S represents ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. That's why S represents notations. In the previous class already given notations, right? So this is the statement. We have to prove this. That means if the equation non-homogeneous equation means here second degree, here power 1, second degree, here it is second degree, but it is first degree. That's why it is the powers are not balancing. That's why it is a non-homogeneous equation. It represents two lines, if the equation represents that means a pair of straight lines, definitely it satisfies abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. It is called discriminant of this conic. abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. It represents delta and also satisfy the conditions h square greater than or equal to ab, g square greater than or equal to ac, f square greater than or equal to bc. Since the pair of lines, that means the equation represents pair of lines, definitely satisfy delta is equal to 0 and also satisfy one of these three conditions. Then the equation represents a pair of lines. Otherwise, it is not represents a pair of lines equation. Now we have to prove for this one. So observe. So this equation, non-homogeneous equation. That's why. So it represents two lines, two individual straight lines, which are also non-homogeneous equations. That's why we have to take the two lines L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0. Since constants are there, since here constant there. That's why the combined equation of these two represents this equation. That's why product of these two, multiply them. So multiply. If multiplying these two terms, which contains x square term and xy term and y square term and x term and y term and constant term, like this. That's why comparing the corresponding terms on both sides, then the coefficient of x square, here a, here L1, L2. That's why L1, L2 is equal to a and M1, M2 is equal to b. That is the coefficient of y square, and the constant N1, N2 is equal to c. The coefficient of xy, L1, M2 plus L2, M1, 2h. Coefficient of x, L1, L2 plus L2, N1, 2g. Coefficient of y, M1, N2 plus M2, N1, 2f. That's all. Now we have to prove for the first condition. What is that? We have to prove that delta is equal to 0. That is the first condition. So we have to consider product of these three boxes. 2h into 2g into 2f. We have to consider 2h into 2g into 2f. Now, what is 2h? 2h is nothing but L1 M2 plus L2 M1, and 2g is L1 M2 plus L2 N1, and 2f is M1 M2 plus M2 N1. Now multiply all these. So you can carefully multiply the terms. First you can multiply these two brackets. So then we get here. Okay. Next, with this one, multiply this bracket, then we get them. After simplification, we have to we have to collect the common terms. It's very carefully, since a little bit difficulty, that means a little bit length is there. That's why now we have to collect the corresponding terms. That's why take common L1, L2. Where it is L1, L2, take common L1, L2. Here observe, here L1, L2, and here L1, L2. Take common L1, L2. So remaining M1 square N2 square plus M2 square N1 square. That's all. The terms completed. Again, take common M1, M2. Here M1, M2. Again, M1, M2. Here M1, M2. From these two terms, take common M1, M2. Then L1, N2 square, L1 square N2 square plus L2 square N1 square. That's all. Again, take common N1, N2. So from this is N1, N2, this is N1, N2. From these two, we have to take common N1, N2. N1, N2 take common, then L1 square M2 square plus L2 square M1 square. So remaining, what are the remaining terms? This one and this one. That's why 2 times of L1, L2, M1, M2, N1, N2. That's all. Now, observe here. This is the form of A square plus B square. A square plus B square. That means M1, N2 plus M2, M1, M2 square, M2, N1 square. That's why we know that M1, N2 plus M2, N1, 2F. That's why the A square plus B square can be written A plus B whole square minus 2AB. Here also A plus B whole square minus 2AB. Here also A plus B whole square minus 2AB. Again we have to substitute. Here instead of this 2F. That's why 2F whole square, 4F square. Here it is B, C, M1, M2, B, N1, N2, C. Same. Here L1, N2 plus L2, N1. That is 2G. That's why it is 4G square. It is A, C, 4A, 2AC. Again this is H, 2H. 2H square, it is 4H square minus 2AB. And plus 2ABC is there. Plus 2ABC is there. Plus 2ABC. Plus 2ABC. Since L1, L2, M, A, M1, M2, B, N1, N2, C. That's why plus 2ABC. That's all. Now, multiply with A here. 4AF square minus 2ABC. 4BG square minus 2ABC. 4CH square minus 2ABC plus 2ABC. That's why these two gets cancelled. So remaining we are going to simplify this. Now we are going to the next step. That is 8FGH is equal to 4AF square plus 4BG square plus 4CH square minus 4ABC. Since there minus 2ABC plus 2ABC gets cancelled. Now divide by 4 or take common 4 and gets cancelled, then it is 2FGH is equal to AF square plus BG square plus CH square minus ABC. So this 2FGH, that means these all terms take this side, then 2FGH plus 2FGH plus 2, that means 2ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0. Okay. That's why, so 2FGH plus, that means ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0. This is nothing but delta. It represents delta. That's why delta is equal to 0. If delta is equal to 0, then the equation represents pair of lines. And this is also represents, that means det notation. Determinant, you know that determinant. So for, we have to take this element, corresponding column and a corresponding row eliminate, then A times of BC minus AF square, like that. After simplification, then we get this is. Now we are going to second proof. H square greater than or equal to AB. Let us consider H square minus AB. What is the value of H? Actually 2H is L1 M2 plus L2 M1. That's why H is L1 M2 plus L2 M1 by 2 whole square. H square. AB. A is L1 L2 M1 M2 B. Now simplify that. It is square by 4. Take LCM. Now observe here. A plus B whole square minus 4AB is nothing but A minus B whole square by 4. So A minus B whole square. That is perfect square. Perfect square is never negative. Perfect square is never negative, always positive. That's why it is positive. Maybe chance 0. Since if they are equal, L1 M2 is equal to L2 M1, then it is 0. That's why greater than or equal to 0. That's why h square minus ab result is greater than or equal to 0. That's why h square greater than or equal to ab. That's why similarly we have to prove g square greater than or equal to ac and f square greater than or equal to bc. That's why this is very important theorem for 7 marks in IP board exam. The most important theorem. Write it fast, all of you. Okay. Now we are going to the questions on the concept. So here observe. Remember here, if the equation represents pair of lines, definitely delta is equal to 0 as well as one of the conditions must be satisfied. Without one of the conditions satisfied, only delta is equal to 0, the equation may not be represents straight lines, may not be represents pair of straight lines. That's why definitely delta is equal to 0 as well as one of the conditions must be satisfied, then the equation represents a pair of straight lines. Otherwise, it is not represents a pair of straight lines. So now we are going to the questions on the concept. Okay, write it fast. This is very important theorem. Okay. Now we are going to the questions on the concept. The first question that is, verify the equation x square plus 2xy plus y square plus 1 is equal to 0 represents a pair of lines. Yes or no? So observe, x square plus 2xy plus y square plus 1 is equal to 0. We will be comparing with the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, where a is 1 and h is half of the coefficient of xy 1 and b is coefficient of y square 1, and there is no x term, x coefficient 0, and there is no coefficient of y that is 0, f 0, and c is a constant 1. That's all. Now we have to find the first condition. What is that? Delta. If delta is equal to 0, so one of the chance for the given equation may be represents a pair of lines. That's why that is formula ABC plus 2FGH minus AF square minus BC square minus CH square. That's why you can substitute ABC, that is 1, so remaining zeros, and CH square 1. So 1 minus 1 0. That's why delta is equal to 0. So delta is equal to 0. Now we have to verify the remaining conditions. H square is nothing but 1 is greater than or equal to AB. What is AB? 1. So 1 is equal to 1. That's why equal to 1. Now we are going to G square. G square condition. What is G square? 0. And AC. What is product of AC? AC is 1. That's why 0 is less than 1. That's why G square less than AC. So not condition. Not satisfy this condition. Not satisfy this condition. Now F square. F square is 0. Again BC is 1. So F square less than BC. So not satisfy this condition. So the equation not represents pair of lines. Since observe, x square plus 2xy plus y square plus 1 is equal to 0 represents x plus y whole square plus 1. So there is no chance for real. X plus y whole square is equal to minus 1. X plus y is equal to root negative. Root negative is imaginary. That's why it is not real. That's why this equation not represents pair of lines. Now we are going to second question. Verify the equation x square plus xy minus 2y square plus 4x minus y plus 3 is equal to 0 represents pair of lines. Now we have to, that means yes or not. We have to verify yes or not. Now given equation, solution for this one. Given equation taken as comparing with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, similar to previous one. Now, so comparing the corresponding coefficients, a is 1 and h is half of the coefficient 1 by 2 and b is y square coefficient minus 2 and g is coefficient of half of the coefficient of x, that is 2, and f is half of the coefficient of y minus 1 by 2 and c is constant. Now we have to verify delta, discriminant of the conic, that is delta abc plus 2fgh minus af square minus bc square minus ch square. According to that we have to simplify, then it is 0. So delta is equal to 0. Now we have to verify these conditions. If these conditions satisfy, then the equation represents a pair of straight lines, otherwise not pair of straight. Of course, one of the condition must be satisfied. That's why h square. What is h? H is 1 by 2. 1 by 2 whole square, 1 by 4 is greater than AB. Since AB is minus 2, that's why 1 by 4 is greater than AB. So first condition satisfied. Second condition, G square. What is G? G is minus 2. That's why G square is 4. 4 is greater than AC. AC is 3. That's why second condition satisfied. And third condition, F square 1 by 4 is greater than minus 6. BC is minus 6. That's why F square greater than BC. That's why the given equation represents a pair of lines. That's why these are the questions depends upon the concept. The concept is the theorem. Theorem is very important theorem. That is non-homogeneous pair of straight lines theorem. That's why you can practice the theorem. You can follow the questions, enter the exercise completely. The questions, all the questions depends upon this concept. Okay, write it fast. Now we are going to the node point for this one. Actually, homogeneous pair of stand from the homogeneous pair of lines equation ax square plus 2hxy plus by square is equal to 0, and stand from the non-homogeneous pair of lines ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. That's why this is the common part for these two. That's why these two are parallel. But this is passing through origin. This is not passing through origin. This is passing through the particular point p alpha comma beta. That is non-origin. This is passing through origin. That's why these two are parallel. That's why these two homogeneous equations are parallel, since up to second degree variable the parameters are same. That's why these two parallel pair of straight lines. Okay, that's why angle for these two equal, since parallel lines makes equal angles. That's why this one theta. If it is theta, this is also theta. That's why we know that already angle between the pair of lines theorem completed. From that cos theta is equal to that means plus or minus a plus b by root of a minus b whole square plus 4h square. Then sin theta and tan theta also there. So according that, that's why these two such that angle between the pair of lines is equal. If theta is the angle between the pair of lines, then cos theta is this formula, sin theta and tan theta. If theta is acute, so everyone is positive. So every function cos positive, sin positive, tan positive. If theta is 90 degrees, then a plus b is equal to 0. A plus b means what? Coefficient of x square plus coefficient of y square. Here also coefficient of x square plus coefficient of y square 0. And that's why the pair of lines represents perpendicular lines. Pair of lines represents perpendicular lines. If theta is equal to 0 or 180, then h square is equal to ab. Suppose we have to substitute the theta 0. Then cross multiplication h square is equal to ab. Here also. That's why if theta is equal to 0 or 180, then h square is equal to ab. Then the pair of lines represents parallel lines. So parallel lines means for homogeneous part h square is equal to ab or h square minus ab is equal to 0. Then the homogeneous pair of lines represents coincident lines. Listen carefully, all of you. Listen carefully. For homogeneous part represents h square is equal to ab. The lines coincident lines. For non-homogeneous part h square is equal to ab, the lines represents parallel lines. So that is the difference between the small difference. Condition is same, h square is equal to ab. For h square is equal to ab, homogeneous part represents coincident lines. For non-homogeneous part represents parallel lines. Parallel lines and coincident lines. There is a difference. Coincident lines, everything same. That means a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Coincident lines are identical lines, are same lines. Parallel lines, a1 by a2 is equal to b1 by b2, not equal to c1 by c2. That's why constant may be differ by constant. That's why here for homogeneous part, coincident lines. For non-homogeneous part, parallel lines. For the condition, h square is equal to ab. Now we are going to the questions on this concept. We are going to the next question. That means depends upon the same concept. If x square plus alpha y square plus 2 beta y minus is equal to a square represents a pair of perpendicular lines, then beta is equal to first option a, second option 2a, third option 3a, and fourth option 4a. So observe, the given line represents perpendicular lines. Already we know that if pair of lines represents perpendicular lines, then the coefficient of x square plus coefficient of y square is equal to 0. That means a plus b is equal to 0. That's why the given equation will comparing with the pair of lines equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. That means it represents pair of lines. Definitely we have to prove delta is equal to 0 or one of the already given there represents pair of lines. That means coefficient of x square plus coefficient of y square. This will comparing them. A is equal to 1, h is equal to 0 since there is no xy term, and b is equal to alpha, and g is equal to 0, f is equal to beta, and c is equal to minus a square. That's why now comparing them. So this is the condition for perpendicular lines. If the equation represents perpendicular lines, a plus b is equal to 0. That's why 1 plus alpha is equal to 0. Alpha is equal to minus 1. Alpha is nothing but the coefficient of y square, that is b. Alpha is nothing but b. So b is equal to minus 1. Right? B is equal to minus 1. Now, one of the conditions, f square greater than or equal to bc. One of the conditions, this is also represents, the equation represents pair of lines. F square, that is beta square, alpha, a, f square, bc. B is alpha minus a square. Alpha is nothing but minus 1, minus plus. Beta square is equal to a square. So beta is equal to a. That's why that is the first option. Now we're going to the next question. If x square plus xy plus my square plus 4x minus y plus n is equal to 0 represents pair of perpendicular lines, then the value of m comma n. The value of m comma n. So this will comparing with the pair of lines equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, similar to the previous one. Then a is equal to 1, h is half of the coefficient of xy, that is 1 by 2, and b is the coefficient of y square m, and g is the coefficient of half of the coefficient of x, f is half of the coefficient of y, and c is constant. Now this is the condition for the equation represents perpendicular lines. Pair of perpendicular lines means a plus b 0. A is 1, b is m. That's why 1 plus m 0. M is equal to minus 1. That's why b is equal to minus 1. Now again it represents. So similar to this one we have to prove, or it represents pair of lines, then delta is equal to 0. It represents pair of lines, then delta is equal to. That's why. So it represents pair of lines, then delta is equal to 0. That's why ABC plus 2FGH minus AF square minus BC square minus CH square, according to that concept, A square minus beta square is equal to 0. Beta square is equal to A square, beta is equal to A. That's why answer is first option. Now I am going to second question. Same, this is also x square plus, that means my square. From this we have to find m and k. So same concept here. It represents perpendicular lines, then a plus b is equal to 0. A plus b is equal to 0, then m is equal to minus 1. So that is b is equal to minus 1. Substitute in place of delta is equal to 0. Then ABC plus 2FGH minus AF square minus BC square minus CH square is equal to 0. We have to substitute there. Then n is equal to 11 by 5. That's why, so answer is minus 1 comma 11 by 5. M comma n. M is minus 1, n is 11 by 5. That's all. Okay. So this is the concept. We are going to another concept in the next class. Okay. Bye.